Hello everyone, welcome back to Checklist by Kaushik Dantu. This is the first video in this playlist and we are going to discuss about types of OS, which is often asked in interviews. You may think it is more of theoretical and there's nothing much to ask, but interviewers will ask industry specific questions like they'll give you a scenario in an industry and they'll ask what type of OS fits here, or they'll ask a specific concept in a OS like what is the role of context switching in time sharing OS, or what is spooling in distributed OS, what is the difference between a network OS and a distributed OS in context of device visibility, and they may give you a scenario and ask like what type of OS fits here and all. So I'll keep the video short. I'll discuss quickly what is different types of OS and what are the advantages, disadvantages, and which where we can get some few MCQs, and then quickly jump into the interview questions. I'll give you a quick one-liner answer, and if you want a detailed answer for each of the question, you can check the link in the description and you can get there entire notes of this video. Okay, now let's start with what are the types of OS that we had. We had batch OS, then we had multitasking OS. Okay, first we'll have multi-programming, then which is having a subtype multitasking, or we can often call it as a time sharing OS too. And we had distributed OS, then we had a network OS, then we had mobile OS too, which is not as much, but the mobile OS, Android OSs are different from the one which we talk, and often sometimes as there is a multi-threading, which is a part of again multitasking one, multi-threading OS and all. So let's quickly discuss about each of them. What is a batch OS? Generally, batch OS is like you'll have a punch cards. Punch cards are something like the set of instructions for each job. Uh, for each job, you'll have these instructions, and you'll send all those punch cards to OS, and OS batches them based on the similarities in the job, and then execute all at a time. So based on because of that, we had some advantages. What are the advantages? Is like generally it saves time, like you don't have to do context switching or anything else, and that's a major use, and we'll use it when there is a repetitive task. Repetitive tasks generally uh, areas where we use batch OS, and there are disadvantages. Of course, there are a lot of features missing, right? We require priority settings. There is no priority settings, and there is no manual interventions. Like for suppose if you want to give an input in middle, you cannot give that. And also, there is no intermediate outputs too. Only one outputs will be there. Like only the outputs are final. Uh, and also we it leads to starvation. This is one of the problem here. Starvation, what is starvation is like y- the processors waits, like so suppose the input devices are idle and the other processes require them, they have to wait for the until the job batch completes, so it leads to starvation. And also idle cases, CPU idle cases are also possible. So these are the disadvantages. And we had multi uh, programming one. In multi programming, generally we have multiple jobs and there will be a job pool. So all those jobs will be there, and there will be some scheduling algorithms that will schedule these jobs and all. Basically, the advantages are you will have you can run multiple jobs at a time, right? Multiple jobs, and uh, all of them are loaded simultaneously. Then we had disadvantages, like sometimes we may require the scheduling is required, and the memory is a major problem here because we use more memory for multiple jobs. All jobs have same memory, right? So, and also the scheduling algorithms are also to be designed here. So these are some common problems in this, and then there's a subtype of it, that is multitasking. So in multitasking, what happens is, also called as time sharing, which is a famous one. uh, the concept of context switching is introduced here, and this is what we are using in our Windows or everywhere. Context switching is like, the OS switches the current state. Actually, what happens is it saves the current running process and then loads a saved state of new process. So in this way, the processes, they give us a illusion that all of them are running parallelly, but they are not running parallelly. The CPU continuously switches the processes, and we feel like it's all of them are running simultaneously. So we can tell, uh, the context switching is a advantage here, and that's how the multitasking is done. Generally, tasks were done using threads or sub processes. We'll discuss what is the process, what's a thread, and what's the process in the future videos. And here we can tell, there's a concept of quantum. Yeah, generally we hear this word in round robin scheduling algorithm, in because it's a time sharing one. It's more related to time. Like there will be a specific time quantum. I mean, for suppose maybe 2 seconds, like that. For every 2 seconds, the OS switches the jobs there, and will give us an illusion that all of them are running simultaneously. But time quantum is the time it gives for each process to run, and after the quantum it will switch. uh, then we had a real-time OS, which is basically mostly as in interviews, like they'll give a scenario on real-time OS, and they'll ask what type of OS you will ask. So you can tell it's real-time based on the requirements they told. Generally in real-time there are very strict requirements, like the deadlines are the one which is a clue for you to identify that it's a real-time OS. There's a very strict deadlines, and you have to use real-time OS. And there are two types here, hard and soft. Generally, hard is like very strict, like you can see that in airbag releasing systems and all, or emergency landing systems. And in soft, generally we have video streaming or kind of thing where there is some exemption if there is a deadline crossed. So we can adjust, if there is a deadline crossed before the video frame came. Okay, we'll discard that and continue whatever whatever the new frames comes, right? In that way, so the soft has some extent of exemption. Okay, then we had a multi-threading one. Generally multi-threading, again, it's a very a famous interview concept actually, and they'll ask you to code multi-threading too. Sometimes if your project has multi-threading, please be prepared with the programming part also, either in Java or Python. So multi-threading OS, the only difference between a multitasking and multi-threading is, generally here, basically we use processes mostly. When I told it's task, I told threads, but generally it's processes. Here we use threads. The difference is like the OS intervention in content switching. Intervention of OS in context switching is the difference. Like generally, in time sharing OS, the OS switches that. In threading, there is no intervention of OS. The OS will not switch the threads. Generally, the process itself identifies which thread to run, and then it switches the threads. That's why there is no intervention of OS in the multi-threading one. That's only advantage. So some it will be little faster than the multi-process multitasking. And there is another one, two main one, and one is the distributed OS. Actually, you get a clue here is like a single system feel like the OS has a multiple connected computers, and all of them has a single OS running over a common network memory. Okay, there will be a common network memory, and multiple components are together connected. Okay, like if you can take which is analogous like the Kubernetes service where there will be multiple pods running and there will be OS working simultaneously controlling all those pods, right? In that way, you can think a distributed OS will have multiple components, which you will not identify which device is doing the job. Like if you had a multiple CPU cores attached there, and you will not be able to know which one is running the task in the network. So the visibility of a device is less here in the distributed OS, like which device is the responsible for. And the concept of spooling, like what is spooling is generally spooling is like it helps the IO devices, right? It maintains buffer. So buffer for the data storage for the parallel computation. Like there are multiple input devices there. Since there are multiple connected components, then we'll have multiple input devices, right? So these all of them get buffered at one place, so it helps the faster IO device input and output rates, IO in the sense. So that's what's spooling, buffer helping the IO rates. Okay, then next we'll discuss about. Okay, network OS has a special features like each device in the network OS has its own OS. Like the devices all are connected over a common network, and you can get the services that can be provided over a common network, like the file sharing, and you can tell some printing, like a printing task, and you can even get some remote logging features, etc. on the network OS. Like example, you can take a Windows server. Yeah. So we covered all the different types of OSs, and now coming to some questions that we discussed at the beginning regarding distributed versus network. The device visibility is more in network. We know the which device is working and the output in the network. Whereas in distributed, it's hard to know. And since it's all a single system that's working, the examples are Amoeba OS and Plan 9 OS. And also regarding context switching, I discussed how the CPU's overhead was there. Like it saves the current state of the process and then loads the previous state. That overhead is there. Because of that, there will be some latency, but which is not existing in the other types of OS. But still, because of that context switching, we are able to run multiple tasks as if they are running parallelly. And we discussed there will be some scenario-based questions also asked, right? Like for suppose they may ask some parachute releasing system, or they'll ask some pacemaker or a heartbeat related system, and what kind of OS you will make. It's having a strict deadlines and it's critical task, so you will tell it's a real-time OS. You will tell there are multiple. If they ask there are multiple components connected on the network or something, and all of them has a single OS, and you can tell it's a distributed OS. So like that, they'll frame the scenarios, and you can tell them. Now you can replay the video and listen the starting questions that I framed, and you can answer them confidently. And in the description, I have pasted a link, and you can get the notes there and other possible interview questions and MCQs. Thank you.